Hi everyone, thank you for having me. My name is Olivia Jack. My talk is entitled The Browser as a Modular Networked Video Synthesizer. Hopefully by the end of the talk, it'll be clear or more clear what I mean by that. Everything I'm going to be talking about is online at this website, Hydra.editor.glitch.me. And it's sort of an ongoing set of research and experimentation and creation that I've been working on for the last year and a half. And so Hydra it's an investigation of collaboration in the creation of live visuals, possibilities of peer-to-peer technology on the web, feedback loops, and it's also a platform for live coding visuals in JavaScript. And so one of the inspirations for this project is a project from 1977 called the Satellite Arts Project by Kit Galloway and Sherry Rabinowitz. And in the 70s, they got access to a satellite and were able to stream video live between two places at once. And this is in the 70s, before the internet, before Skype, and they started experimenting with this, just sort of streaming video and putting images on top of each other, mixing them together, overlaying them, and seeing what happened when they started experimenting with this. And one of the things they talked about with their project is this marks the first time that the geographically dispersed electronic image was contextualized as a live immersive place, where artists and others could convene and co-create together on a scale that could be as culturally inclusive as desired. And I want to focus on the live immersive place piece of this because I think all they're doing, they're sending data between two places, right? And they're talking about how just by putting these two images on top of each other and seeing them live, that it's creating this space that's not there and it's not there. It's sort of some third space that's a combination of these two spaces. And I think now with the web, we use this kind of metaphor of a place a lot, like a website. It's a site. It has an address. You go to the address. You're at the website. And it might just seem kind of like nitpicky, but it's also, it's kind of talking about a way that we're engaging with these technologies. But what's really happening when I go to a website, my computer is sending a message to a server somewhere. The server is responding with a message. And so I'm not anywhere when I go to a website, but we have these sort of ideas about how we talk about the web and how we talk about how we engage with the web. That to me, it's just sort of interesting to be aware of them and start to dissect them. And especially just in the 70s, this was like, wow, what do you mean we can see live video from two different places at once? And what are the possibilities of this? And I think sometimes when technology just comes out is when people are often the most experimental with it. And so fast forward to now, there's this protocol called WebRTC, real-time web streaming, that lets you, it's a browser protocol for streaming video, audio, and data directly between clients. And so one of the interesting things about WebRTC is that although you need a signaling server to sort of set up initial handshakes between clients, once clients are connected, they're basically just sending video or audio or data between one another. And about 4 or 5 years ago, I started experimenting with this protocol, making sort of little video chat applications, and it sort of was just kind of amazed that it's not that hard in JavaScript to send video everywhere. And so I'm still kind of interested in this protocol, and I think lately there's been a lot of exciting developments with this, such as WebTorrent, like BitTorrents running on the web, or Beaker browser, and different sort of peer-to-peer applications of this, of saying what happens if we don't necessarily depend on a server for everything, or on centralization for everything. And so this diagram kind of gets thrown around a lot, but on the left is like a really centralized network, and towards the middle, a more decentralized network, and on the right, a more distributed network. And one thing that WebRTC enables is possibly more things like on the right. But one thing that's been sort of interesting to me is seeing a lot of peer-to-peer technology that often, although it's it has the opportunity to connect people, like the diagram on the right. Often what happens is sort of replicating a centralized database, such as with Bitcoin or something, you're creating a centralized database of transactions, and so everyone still sort of receives the same information, and in some ways it's recreating the experience of a centralized database. And so experimenting with this video streaming, I got interested in sort of different ways of thinking of using this kind of client-side peer-to-peer network. And so one of the things that really inspired me sending video around the internet is analog video synthesizers. And so what's an analog video synthesizer? This is an example also from the 70s. It's the Sandin image processor, created in 1971 by Daniel Sandin. And basically, each of these boxes either generates a series of electrical signals or transforms a series of electrical signals. And when the signal gets to the screen, it creates a pattern. And then the order in which you connect the boxes sort of creates different possibilities for modifying and changing the image. And so what I was interested in is kind of sort of seeing similarities between this thing where we can send lots of video streams around, and this thing over here, which is sending lots of signals around, and the way and the order in which we're sending them can create different creative possibilities. And this is really, I had no like specific goal in mind with this. It's sort of like, oh, I just want to play with these web protocols. And it's not, in this case, not really thinking of a website as a place or a site, but thinking of it as a flow of information. In this case, sort of a signal flow. And so this is sort of was like an initial experiment that I did with this, which is basically, here I have a bunch of windows connected via WebRTC. In this case, they're all on the same computer, but they could easily have been, you know, one in one country, one in a different country, connected over the web. And here on the left, I'm creating an image, and I'm sending it as a video to here and combining it with this one. And then I'm sending other videos. Here's the webcam, and then combining it with what's on the bottom right. And again, I just sort of started playing around with these things, and as I didn't exactly know what my goals were with it, I started live coding in the console just to sort of experiment and be able to live change these things. And it's sort of like, it's both a visual experiment, but also sort of a conceptual experiment of what happens if we connect in these ways and how can we maybe collaborate or something. So this was an initial experiment, and then it turns out it's not that practical all the time if you're on the same computer to be sending video streams. It's like takes a lot of processing power if you're just on the same computer. And so this experiment led to a node module called RTC Patch Bay that just, for me, made it easy to send these video streams and sort of reroute them. And then I started making this sort of in-browser editor to play with this, and I'm gonna go to right now. Let's see. And so this platform called Hydra that I've been working on, it lets you send video streams to other people who are connected, but it also lets you kind of play with this way of making images directly within the browser. And so I'm going to actually clear the canvas right now. And so drawing from analog synthesizer world, one of the basic things that you can make in Hydra is an oscillator. But then when you just write oscillator, you don't actually see anything. And so then to connect it, to actually see it, you have to connect it to an output. And so I'm doing Control-Enter to execute this code. And so here I have an oscillator, and I'm connecting it to an output. And I sort of use functions to correspond to this idea of the analog modular synthesizer, and then chaining the functions as sort of the patch cables connecting the different pieces of the analog modular synthesizer. And then the parameters here can correspond sort of like turning the knobs of the analog synthesizer, where I can change certain parameters. And so here I'm changing the frequency of the oscillator, how fast it's moving, and how separated the colors are. And then I can add more chained functions onto this, so more transformations of the signal similar to the boxes in the modular synthesizer. And so I can keep adding. There's oscillator, rotate, and now I could add a kaleidoscope. Could change them, repeat the kaleidoscope. And so one of the things also with this that's interesting to me is it's sort of a lot of the ways that we make graphics on the computer use also different analogies. For example, canvas. It's like the idea that you have a canvas and you're drawing things onto the canvas, or using Microsoft Word or something. It's the idea that you have a document and you're typing text onto it. And all of these analogies kind of create a framework for thinking about making things using the computer. And so instead of using either the idea of a canvas where you're drawing shapes, or using a 3D rendering thing like 3JS where you have a camera and a mesh and lights and all this stuff, here I'm really interested in this idea of signal flow, and using signal flow as a way to create images. And all of this each function corresponds to a GLSL shader function, and a shader is a program that runs on the graphics card, and it basically is given a coordinate and outputs a color in its sort of most basic sense. And so each of these functions either transforms a coordinate to a color, transforms a color, or transforms a coordinate space, and then adding them together kind of lets you experiment with these things. And of course, the order that things are in matters. So like if I put another rotate here, then I'm gonna start rotating afterwards. And I could also, instead of using an oscillator as a source, I could use, for example, I could use a camera as a source. And so it's kind of dark, but that's all of you. And so I can also sort of apply transformations to this. So let's see. Yeah, it's a little It's a little dark. I'm going to switch to my camera so maybe we'll see better. There we go. And apply transformations. And so now we just sort of have one source and one output, or I've shown you, and it could execute different code to sort of switch back between the two. But with that whole analog synthesizer, there's all these options for like patching things into each other. And so in this system, in order to be able to do that, I actually have 4 sort of virtual outputs with different names. And so I could send the oscillator instead of to the first screen, I could send it to the second screen, which in this case has a name O1. And I'm going to simplify this a little here. So here I'm sending the camera to the first output, or O0, and I'm sending the oscillator to the second output. And then what I could do is actually blend these together. So I could take O0 and blend it with O1 and send it out to O2 here. And so here I'm blending the two together, and if I change one of them, it changes all of them. And again, this is all running directly on the graphics card through WebGL and shaders. And similar, if you're familiar with Photoshop or video editing software, there's different ways of compositing pixels together. So here, I'm taking the difference between the colors. If you think of each color as a number between 0 and 1 RGB channels, and then you can do different sort of arithmetic. But then another thing that I borrowed from analog synthesizer is not just combining colors together, but it's actually using the colors of one thing to affect the coordinates of another thing. And so here it's using the oscillator to sort of warp the initial image. And I'm all doing this sort of in separate function chains, but I could also do it all sort of together. And so I could just here say, I'm going to take this and modulate it with an oscillator. I'll just show here. And I could, I don't know, put another oscillator on top here and just keep kind of chaining all these things together, and it creates really complicated patterns really quickly. And this was just really fun for me. And then, so using different web APIs, also you can not just use the camera as an input, but also lots of other things. Oh, and this is one of the things that Dan Sandin said about this Sandin image processor in the 70s, is the modules are designed to maximize the possibility of interconnection, thereby maximizing the number of possible modifications of the image. So that's like, when I'm thinking about the functions that are there, it's how can these functions really maximize the possibilities of the way that you can mix them together. And so this is using the screen itself as an input. These are sort of experiments that I've done using this idea of the video synthesizer. This is using my Twitter feed as an input, using the desktop capture API. You can use any window as an input. This is using Google Maps as an input, and sort of experimenting with it. And this is using a live stream of an aquarium and a live stream of Times Square, and then live coding them together. And this is sort of going back to the satellite arts project of just sort of combining two live things, and what kind of possibilities or ideas about those two spaces arise by putting them on top of each other. And so another thing that, I'm gonna clear this here, that is really exciting for me to experiment with this is video feedback, or sort of using the output of something as the input to itself, or in other words, sort of recursion. And so here, let's see. So here's the camera. I'm actually gonna switch cameras here to the other one. And so the basics of video feedback is just pointing a camera at its own screen, and sometimes it can create really complicated things. But when I'm holding a camera here, it's not very precise. And so I could actually just do it sort of within the code. So for example, I could here make a shape. And then I could blend it with its own output, which is O0 in this case. But because it's blending the same thing with the same thing, it just ends up also being a triangle. But if I blend it with itself and then repeat the entire thing, add a shape on top to the repeated output, it gets more interesting. And so we get sort of a fractal, which is a form that repeats itself at different scales. And so just using this idea of a video feedback and pretty simple code, then you get something that's as complex as a fractal. And so another example is here. I could go back to the camera. Or actually, another example. Oh yeah, I'll go back to the camera. And so I could blend my face with itself. So here we go. And so then I just start to get these sort of trails. But then if I use that modulate function again, and so I actually use the colors to affect the coordinates. And so each frame update, I'm sort of using the colors that were there to affect the coordinates. And because of feedback, it ends up being this sort of liquid effect. And it turns out this is kind of similar to how fluid dynamics works. You use textures to talk about pressures and velocities. And so this is exciting to me because it's sort of, the code isn't that complicated, but these things that are supposedly computationally complicated, like Navier-Stokes fluid dynamics and stuff, maybe we could have sort of an intuitive understanding of them by thinking about them in sort of a different way. And so, I close my slides, I guess. Oh yeah, you could also use like a canvas as an input, which is kind of fun. And yeah, I've just kept playing around with this sort of this thing. This is reaction diffusion made using feedback. And this is one of the things that Dan Sanded said in the 70s about the idea of the feedback loop is put yourself in a feedback loop. Yes, the reason you put yourself in a feedback loop is so you can learn something, or rather learn to do something. You know, you do something and the results get processed somehow, perhaps just by yourself, just looking at it, and you do another thing and the results of that get processed, and your action can constantly be tuned or corrected or refined by what you see. And so this has been interesting to me because although I've built this software from basically scratch, like there's almost using no libraries and stuff, but I still don't know what's going to happen, and having the editor there and being able to change it in real time and see the results is sort of really resonates with me, both as an artistic process as well as a process for developing code, and just sort of investigation as well. And so also one of the things I've done is made a Twitter bot where you can post a sketch to the Twitter bot, and there's actually, and anyone who's different people who've been using the editor can post something here, and then if you actually click on it in the Twitter bot, it directly opens the code, and so then you can directly edit the code here, and so here I'm editing this, that got a little fast. And then I can upload it again, and here, let's say JSConf.Asia, and then upload it, and we'll see if it shows up here. But, yep, there it goes. So, it... And so it shows us what we just did, but it also shows the sketch that it was sort of based on here, and this one was based on one earlier. And it's thinking about like, oh, we're all just kind of exploring the possibilities of this. I think I'm almost out of time. Yeah, but I wanted to just quickly mention this idea of live coding. So I've started I live code visuals with this, so sometimes in clubs or in different events with experimental music, and I write code live to make visuals, and there's another people all over the world doing this using different languages and sort of experimenting with ways of programming and sort of showing the code while they're performing. And there's this language called Tidal Cycles that's for making music, and it has somewhat similar ideas as Hydra for making visuals, in that although it's in Haskell, but everything that you write in Tidal is sort of a transformation of a pattern in time, and using that you can make music. So, oh yeah, we have a live coding group in Bogota. There's little groups all over the world. There's one in India, and I'm meeting with some people in Indonesia next week and stuff. So, this was last week in Bogota, using Tidal to make music and Hydra to make visuals. Anyways, thank you so much.